So the area of the square equals 16 centimetres squared. Now we want to find half of that to find the area of the triangle. Half of 16 is 8. So the area of the triangle equals 8 centimetres squared.
Right, let's move on to a parallelogram now. First thing we do is we count the number of whole squares that we've got. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 whole squares.
Now let's count the part squares. It's 1, 2, 3, 4, 5, 6. Now if we put those together, in this case they add up to 3 whole squares. So those 3 whole squares plus the 9 we've already got gives us 12. So the area of this shape equals 12 centimetres squared.
The area of any shape can be estimated by dividing it into smaller parts and counting them. It's often easiest to divide the shape into small squares. Take a look at this real-life example which involves measuring an awkward shape like a leaf.
Anna is measuring a leaf so she can calculate the amount of carbon dioxide it absorbs per minute. She'll do this for a sample of about 10 leaves to compare the efficiency in different parts of the canopy. She needs to know how much carbon dioxide each leaf absorbs in relation to its surface area, so the area needs to be estimated. How would you do this? How would you estimate the area of a leaf? When we measure a line, we fill it with units of length which we can count. This line is about 4 units long. When we measure a surface, we must cover it completely with units of area, all the same size, so each covers the same amount of surface. These pieces are all the same size and they fit together without gaps, but you could hardly say the area was 8 birds. You could use hexagons or possibly triangles, but it's easiest to use squares. We can find the area of this shape by counting the number of squares which cover it. Let's start with the whole squares. Up to 28. But we still haven't found the whole area. Some squares lie partly inside and some partly outside the boundary. How would you deal with these? One way is to assume that the boundary squares which are more than half full make up for the squares which are less than half full. So we could estimate the number of whole squares by counting all the boundary squares and dividing that by 2. That equals 19. This gives a total area of 19 plus 28, 47 squares. In the laboratory, Chris puts a dot in each whole squares. These squares are 1 centimetre each way, so they have an area of 1 square centimetre. She does the same for the number of part squares and divides this by 2 to give an estimate of the total number of squares that the leaf covers. So this leaf has an area of 37.5 square centimetres, and that seems to be a fairly representative size. With this information, she can estimate the amount of carbon dioxide absorbed and the amount of oxygen given off for the whole of the canopy, indeed, for the whole of the rainforest. Trees are vital for our survival, and by using the data collected, scientists are able to advise countries on planting species of trees and planning forest development in such a way that they won't run out.
The area of a circle can also be estimated. Take a look at this. What is the area of this shape? A circle. we can break it up into squares. It's about 3/4 of the area of the square that surrounds it. The side of the square is the diameter of the circle. Alternatively, we can cut the circle into equal sectors. This shape is, well, nearly a rectangle. Half the circumference of the circle roughly forms the length or one side of the rectangle, and the height of each of the segments is approximately the radius of the circle. But we can be more accurate than this when finding area. The area of a rectangle or square can be found by multiplying the length by the width. Look at this rectangle. Let's write down its dimensions. Length equals 9 centimeters. Width equals 7 centimeters. Area equals length multiplied by width. So the area equals 9 multiplied by 7. That's 63 centimeters squared. The area of a triangle is base length multiplied by the height divided by 2. In this triangle, its base length equals 5 centimeters and height equals 8 centimeters. Area equals base multiplied by height divided by 2. That's 5 multiplied by 8 divided by 2, or 40 divided by 2. So area equals 20 centimeters squared. The area of a parallelogram is base length b times height h, or b times h. Let's take another look at that triangle. Let's copy it, rotate the copy through 180 degrees and join it to the original triangle. Now we've made a parallelogram. The parallelogram should have an area that's twice the area of the original triangle. The base of the parallelogram is 5 centimeters and its height is 8 centimeters. Its area is base multiplied by height. That's 5 multiplied by 8, which is 40 centimeters squared. That's indeed twice the area of the triangle. Finally, the area of a circle is pi multiplied by the radius squared, which means multiplied by the radius, then by the radius again. So this circle with a radius of 3 centimeters has an area of pi, or 3.14, multiplied by 3 multiplied by 3 again, which comes to 28.3 centimeters squared. Now, although you'll be given most of the formulae at the front of the test paper, you should still make sure that you're familiar with them and that you know how to use them. So why not rewind the tape and check that you can calculate the areas of the shapes we've just shown you using the correct formulae. Otherwise, you can move straight on to this next test question. Part A. The diagram shows a rectangle 18 centimeters long and 14 centimeters wide. It's been split into 4 smaller rectangles. Write the area of each small rectangle on the diagram. One has already been done for you. What is the area of the whole rectangle? What is 18 multiplied by 14? Part B. A circle has a radius of 15 centimeters. What is the area of the circle? You have to write your answer in centimeters squared. Show you're working. So, how did you fare? Well, let's work through the question part by part. For part A, you're asked to find the area of each small rectangle on the diagram. Now find the area of the whole rectangle. And finally, you're asked what 18 times 14 is.
You're shown a rectangle 18 centimeters long and 14 centimetres wide, split into 4 smaller rectangles, and you are asked to find the area of each small rectangle on the diagram. The question says that one has already been done, so look at that first. It is this rectangle here, which is 10 centimetres long and 4 centimetres wide. You find the area of a rectangle by multiplying length by width. So that is 10 by 4, and that's how they got the 40 square centimetres here. Now look at the rectangle above it. In fact, it is a special rectangle because it has a length of 10 centimetres and a width of 10 centimetres, so it's a square. So its area is 10 multiplied by 10, so that's 100 square centimetres. Now look at the rectangle next to that square. That has a length of 8 centimetres and a width of 10 centimetres. So its area is 8 multiplied by 10, so that's 80 square centimetres. Finally, the rectangle below that has a length of 8 and a width of 4. So its area is 8 multiplied by 4, which is 32 square centimetres. Now, remember that area measures space covered, so each of these areas tell us the space covered by each of these small rectangles. So to find the area of the whole large rectangle, you can just add up the areas of the smaller rectangles that make up the large one. So that's 40 square centimetres, plus 100 square centimetres, plus 80 square centimetres, plus 32 square centimetres. And that comes to 252 square centimetres. And finally, you're asked what 18 multiplied by 14 is. Notice that the whole large rectangle has length 18 centimetres and width 14 centimetres. So its area is 18 multiplied by 14, and we already know that its area is 252 square centimetres. So 18 multiplied by 14 is 252.
For part B, you're asked to calculate the area of the circle.
This circle has a radius of 15 centimetres, and you need to calculate its area, not forgetting to show your working. Write down what you know first of all. You know the radius equals 15 centimetres. The formula to find the area of a circle is pi multiplied by the radius squared, which means pi multiplied by the radius multiplied by the radius again. So the area of this circle is pi multiplied by 15 multiplied by 15 again. Your calculator should give 706.5 square centimetres. If your calculator does not have a pi button, use the approximation 3.14 for pi.
Right, now